Okay, one of the last couple of problems in section on division of polynomials, it says to factor the polynomial y equals 2x cubed plus 7x squared minus 14x minus 40, given that negative 4 is a 0. I'm going to tell you to always go graph these polynomials first. And so if I look over onto my calculator and I had put in that polynomial into my y1 and I go look at the graph, I see that negative 4 is indeed a 0, right? What else is a 0? Negative 2 and possibly somewhere between 2 and 3, right?
Yeah.
All right, so I know that negative 4 is a 0, so I'm going to go put negative 4 into my half box. And the numbers that go across the top belong to the coefficients out front. So I have 2, 7, negative 14, and negative 40. I don't need any placeholders because I have an x cubed, x squared, x, and a constant, right? Okay, to do synthetic division, I drop the 2 down. To go back upstairs, I have to multiply that number by the number that's in the half box. So 2 times negative 4 is negative 8. And then when I go down, I add. 7 plus negative 8 is negative 1. To go back up, negative 1 times negative 4 is 4. Negative 14 plus 4 is negative 10. Negative 10 times negative 4 is 40. Negative 40 plus 40 is 0. And that's a good thing I got 0 there, because that means that negative 4 was a 0, yes? Okay, I can stop there, because what's the answer down here? What's that corresponding polynomial? 2x squared minus 1x minus 10. That factors, yes? It factors to 2x minus 5 and x plus 2. Okay, your 3 factors. If I want to factor this polynomial, using this 0, I get x plus 4 as a factor, yes? And then I had these other 2 factors, 2x minus 5 and x plus 2. Continuing on with the problem, if I wanted to solve, setting that initial polynomial equal to 0, we just factored it to x plus 4 times 2x minus 5 times x plus 2. If I set each of those factors equal to 0 and solve for x, I get x equals negative 4. I get x equals positive 5 halves. And I get x equals negative 2. These 3 numbers, negative 4, 5 halves, and negative 2, corresponded to my x-intercepts. Everybody following? When you're finding the zeros, aka the roots, you're finding the x-intercepts of that polynomial function. Something I want to show you, if I go scoot this down, you do not have to write this down, but it's coming in this next section. Had I only known the negative 4, and I went and looked at my graph and I saw that negative 2 also worked, watch this. I can put a negative 2 here, and I'm going to use these numbers and do synthetic division on it. If I drop it down, 2 times negative 2 is negative 4. Negative 1 plus negative 4 is negative 5. Negative 5 times negative 2 is 10. Negative 10 plus 10 is 0. What other number could I use in a half box? 5 halves? So if I go do 5 halves in a half box, Drop down my 2. 2 times 5/2 is 5. So what are my 3 zeros for that polynomial? The 3 zeros are -4, -2, and 5/2. We're going to be doing this a lot in the next section, where we keep dividing the polynomial, keep using the synthetic division, and it keeps decreasing the degree of the polynomial that results by 1, right? Just kind of keep that in the back of your mind. Now, a question that was asked yesterday. Does it matter which 0 you do first in your half box? Does not matter. If it's a 0, it's a 0. And you're going to reduce it. All right. Last example in this section. Write a polynomial of degree 3 that has zeros 1/3, √3, and -√3. You want 3 zeros. Okay, the first thing I do, I say that x is supposed to equal 1/3, correct? So that means 3x is equal to 1. So 3x minus 1 equals 0. This is going to be one of my factors. X is supposed to equal √3. So x minus √3 equals 0. This is one of my factors. And last but not least, x is supposed to equal -√3. So x plus √3 equals 0. That's a third factor. So if I'm trying to write a polynomial of degree 3, I have 3 linear factors, 3x minus 1, x minus √3, and x plus √3. Okay, let's go multiply these things out, these 3 factors out. I'm going to FOIL those 2 factors. So I have 3x minus 1 times x squared plus √3x minus √3x minus, what's √3 times √3? 3. The inner terms are gone. The middle terms are gone. So I'm left with 3x minus 1 times x squared minus 3. Now I need to go FOIL again. I get 3x cubed. Outer terms give me minus 9x. Inner terms give me minus x squared. And last terms give me plus 3. I need to write that in decreasing order. That should be 3x cubed, sorry. So I get 3x cubed minus x squared minus 9x plus 3. That is a degree 3 polynomial, degree 3, that has x equals 1/3, x equals √3, and x equals -√3 as zeros.